I've sent.
Yes,
Hello,
please.
Professor. I've sent his name.
Yes, I'm listening.
I'll send his name. Is try. I think Traro or something like that.
Okay, then if they are able, then we are waiting. If they don't, then I'm going to present the file, okay? Because it is already 8 o'clock. Uh, then I think it is the time to start.
Okay.
Okay. You see the chapter 3, the consumer preferences and the utility function. Today, I'm going to present you the consumer preferences, utility function, and the all theoretical knowledge. After I give you, then we will give you the application also online. Then you will go through with step by step to solve the equations and the problems in this direction. So you don't have to worry about, and I will send you the exercise also, and then the solutions. Um, the outline, if it is given to you, the introduction will be then is, as I mentioned to you, the consumer preferences and the utility function. You know, the utility function is related with the consumer preferences, and the utility, which is going to be maximized and optimized in this chapter. And we will then concentrate to the diminishing marginal utility, the indifference curve that you are probably knowing from the former classes, the marginal rate of substitutions, the substitution and the complement and substitute goods will be given in an let's say applications, and then special functions is in forms introduced. Supply demand model, which is exercised and analyzed in the former chapters, is now going to be deepened with the demand side. Now we are going to the utility, which is mostly the consumers' preferences and consumers' let's say surplus is concentrated, and how will increasing and the enlarging it, and what the real wage effect on the output is questioned. And in the models, we sum each individual's demand to obtain the market demand curve, and the individuals, whether it is going to be decided to consume and how much it is going to be consumed and what is the preferences, and for being able to optimize their preferences and utility is introduced to you, and how it is going to be related to the other side of the let's say supply side will be introduced. We need to develop a model about the individual and the consumer behaviors. And the model is based on the individual's taste and preferences. As you know, the consumer preferences is mostly dependent to the utility function, but utility is directly related with the quantity which is going to be bought and which is going to be consumed, whether it is sufficient for people's satisfaction or not, whether they are going to satisfy their utility with the existing conditions is going to be considered and questioned, and the consumers budget constraint, indifference curve, and all these things will be given to you in this lecture, and the next week lectures with the applications will be introduced to you, and what the let's say necessary foodstuffs, luxuries, inferior goods, the given paradox, how is affecting and changing these preferences will be analyzed and questioned. Let's go to the behavior, consumer behavior, and check up how these preferences realize. When we are looking to the consumer preferences, which is telling us how the consumer will rank any two basket of goods, because we are creating a scenario here, and we are trying to make it, simplify it for making more clear, and you are going to understand better with these two-dimensional graphs, because if it is three-dimensional or more, then this will then make it more complicated. Therefore, we are going to summarize it. We are going to make it simple for being able to understand how this is affecting and changing the consumer utility and, of course, preferences. This basket, also called the bundles, is directly related with the budget constraint or budget line. It is the financial ability or the disposable income of the consumers. Therefore, in this direction, we are going to concentrate to the uh, budget line, the indifference curve, and the intersection of these, whether it is going to be satisfied or not. We will see how it is going to be optimized depending to the preferences, and the combination of the goods and services will be introduced. When we are going to look to the properties of these consumer preferences, we have some assumptions for this behavior. When we look to these properties, the first, the important assumption is the complete. The consumer is able to rank any two baskets for baskets A and B because you have preferences. As in the market, when you go to the market, you have always preferences to determine which product you are going to buy and which combination of this will be the best possible option for you. And if she prefers basket A to basket B, we will then write as A is more than or equal to B. And if she prefers basket B to A, then we will then write is B is more than or greater than A, and or is equal. And she is indifferent or is exactly not any preferences between these two, then we will then suppose equally happy either or A or B will then supposed to be is indifferent. And assumption two says the transitive preferences, which is going to direct to the next one. Then the A is supposed to be more than B preferred, and then B is supposed to be more than C preferred. Then we may say A is preferred to C, not C preferred to A. Therefore, this is how it is going to be. Therefore, if some assumptions is not given, or if some preference is not given but directly or indirectly is given and explained to you, then you will then able to determine which is the best option for you. The third property is the monotonic. More is better is the preferences. Having more of good is better for the consumer if more is better. She likes more food better than less food is supposed to be. More is better is not always, but it is supposed to be. More is better assumption is also known as the property of satiation, sorry. If assumes are looking at what economists call a good, something we want more of, we are not looking at a bad, which means the pollution. Example, she would prefer basket A to B, G or J because she receives the same amount of good in these three baskets, but more clothing at A. Let me change my microphone and my hold on a second. Okay. Evet, as I said to you, she would prefer basket A to B or G or J because she received the same amount of food in these three baskets, but more clothing at A, if we suppose so. And when we are looking to this graphical illustration, which bundles are better because more is better, if it is supposed to be, as you see, it is given on the numbers here, units of clothing and units of food. And when you are going to look the combination at D, there is 10 to 20, which is somehow less than G, but more than, let's say, D. Therefore, if you are enlarging and moving away from the origin, this better off position is becoming enlarged and increased, and it is depending directly to the consumer's preferences. We may not say which combination is the better for any person or any consumer, it is depending directly to this combination. But we may say if it is on the same indifference curve, it is better off or it is same. If it is above or below on the indifference curve, which is going to be introduced, then we may say as much as you move from D to G, from G to A, is going to be enlarged and increased because as you see the combination and the, of course, preferences become enlarged. Therefore, from this point of view, you may not determine whether E or B or G is going to be determined. It is directly related with the person who is going to consume the combination of these two, which is supposed to be better off. For some person who is going to consume more food, probably B is better. And for some who is going to consume more clothes, then E is probably better. But if it is going to be questioned which one, then you are going to understand as much as you are moving away from the origin, this better off position and this is enlargement of the combination or bundles will be enlarged. And it is, of course, here is roughly indicated, and we are not able to determine which combination is going to be the best possible option for the given scenario. When we are looking to this graphical illustration, so table, there is age, number of subjects, and intransitive clauses, which is given here. The intransitivity and the age is also given. As you see, the number of subjects and the choices, as it is indicated here, as much as it is the age is enlarged and increased, the subject is also increased. But on the other side, the intransitive choices is becoming as a percentage reduced. Therefore, if the age is 4, the subject is 39, and the choice is 83, is probably at that age is the best possible. But when it is going to enlarge and increase to 9, age of 9 becomes 52 to 57, the intransitive choices, then we are going to enlarge and increase this. And when you become adult, then the number of subjects become 99. And of course, intransitive choices become smaller because you are becoming more consciously determined what the preferences make you more better off regarding to the younger ages, let's say. The ordinal and cardinal ranking is also important in the, let's say, consumer preferences. Ordinal ranking giving you or gives you an information on how consumer ranks different baskets of goods, but it does not say but by how much, which means 2 times as much. This is how we view preferences. And the cardinal ranking gives us information on the intensity of the consumer preferences. They like basket at 10 times more than basket B, which is the comparison is here, is in the subject. Therefore, would be hard to say I like eating pizza out 10 times 5, 10 times more than eating bad Chinese, and putting an exact number to our preferences is hard. This is why we use ordinal ranking for consumer preferences, because you are not going to make this comparison exactly because the preferences are not very, let's say, unique and very, uh, let's say, similar to each other or each person. Students take an exam. After the exam, the students are ranked according to their performance. An ordinal ranking lists the students in order of their performance. Harry did best, Joy did second best, Betty did third best, and so on it goes. And cardinal, then you are going to put the numbers now. Then ranking gives the grade of the exam based on an absolute grading standards. Harry got 50, Joy get 100, and Joy the second time better than Harry, you may say. The utility function, when we are looking to the utility function, which is the most important part of the consumer preferences, measures the level of satisfaction that a consumer receives from any basket of goods. And the function is represented as U is equal to function of x1, x2, x3, and xn, where the x are the quantity of n goods that might be consumed in a period. And is utility ordinal or cardinal is going to be, then utility is an ordinal concept, and the precise magnitude of the number that the function assigns has no significance. The utility function difference in magnitudes of utility have no interpretation per se, and utility not comparable across individuals. Any transformation of a utility function that preserves the original ranking of bundle is an equal good representation of preferences. When we are looking to this utility function as it is given on the graph, you are understanding there is a good which weeks consumption of muffins and the total utility of muffins is represented. As you see, it is almost the same for the production function. The utility function is directly related with the increasing of the amount of the utility, and the muffins is not directly related with the enlargement of the utility or increasing the amount of the let's say utility and the satisfaction. While you are enlarging and increasing it, it is decreasing amount of increase realized as it is you are drinking the first glass of water when you are thirsty. This will give you the highest satisfaction. As you see here, the satisfaction for the first weekly consumption of muffins is represented in the first week. It is the 1. And after the second week, as I said to you, the first glass of water which you are thirsty after jogging will give you the most satisfaction. Then the second will give you lesser, but again is satisfying you. Third, fourth, but at the end of the day or at the end of the hour, you will start with this consumption and you will not anymore accept this drinking water. Or similarly, the muffins will becomes to the end point where it is the maximum point, and after this you are not able to get any more satisfaction or any more utility from this product. As it is represented here, the second week the utility is decreasing half of the first week, and after the second to third this is decreased to 0.25, which is the half of this second week. And this shows the utility function is also decreasing amount of increase realized and becomes to the optimal position where it is this U shape, inverse U shape becomes to the optimum position where it is the top. And then this will then brings you to the maximum, and this will then goes to negative, which is not good. And this utility function represented as u is the function of y is equal to y power of 5, as it is represented on the curve. And when we are looking to the utility and marginal utility, the rate at which total utility changes as the level of consumption rises. Each new muffin makes you happier, but makes you happier by smaller and smaller amount than the former that you consume. Then the utility function represents marginal utility for y is the of course muffin. Delta u over delta y is then the delta u over delta y represented the slope also, and it is because the two different point of any curve will give you the slope, and this slope will give you the utility for this given example, and this is then the utility function and marginal utility formula. And the marginal utility, when it is going to be defined more than one good, which we are going to represent for the two-dimensional, the marginal utility of a good X is the additional utility that the consumer gets from consuming a little more of X when the consumption of all the other goods in the consumer's basket remain constant. Delta U over delta X, Y is supposed to be held constant, and marginal utility of X supposed to be delta U over delta X, which is represented with this small one. And the marginal utility of X is the slope of the utility function with respect of the X, as I mentioned to you. And the principle of the diminishing marginal utility states the marginal utility falls as the consumer consumes more of these goods, as I mentioned for the water example. If you have any question, you will ask me. The marginal utility, because this is theoretical, but this is good part where you are going to understand how this is realized, and we will then start exercising in the next week maybe. Marginal utility of muffins is represented here. As you see, this is then the indifference curve given here. If more is always better, the marginal utility must always be positive, and diminishing marginal utility is also subjective. A positive marginal utility means you like the good, otherwise you will get zero or perhaps negative marginal utility. As you see here, between first week, second week, and third week, there is a diminishing marginal utility from 1 to 0, so from 1 to 0.50 and from 0.50 to 0.25, which is decreasing amount of increase of the marginal utility is subjective. And when we are representing this in three-dimensional, graph, where we are concentrating to the two units of products, let's say clothing and food, and the utility function is on the y-axis. It is represented as much as you see the utility function and the indifference curve is represented here. As you see, the utility function and the indifference curve is going to enlarge and increase as much as it is moving away from the origin, and U4 represent the same utility for the ABC on the utility and the indifference curve, where the let's say A, B, and C is set on the same line, and for the U6 at U6 or on the U6 you have again on the same line similar utility but higher than the U4, and U8 again on this curve you have same utility and higher than U6 and U4, and U10 represents again the highest indifference curve and highest utility, and you have now better off from the other utilities which is given on the graph. The indifference curve, as you are observing from the former graph, is convex to the origin, and between clothing and food, you are having some preferences. And at B, as you see, you have almost a similar combination. At A, you have more clothing than food, and at C, you have more food than clothing. Therefore, it is directly related with the preferences of the people which they are going to consume and prefer some goods to other. Two goods graph is represented. Along curve, consumer is indifferent between each of the bundle for food and clothing, and same level of utility for bundle A, B, C is then given because we are on the same indifference curve line, which the utility function is for. Then here we have the second utility function, which is U6, and this is higher than the U4 and will give you better of comparing to the other lower indifference curve 1. An indifference curve, but more is better, so are better off as we move away from the origin. As I mentioned to you, as much as you're moving away from the origin, the utility and the indifference curve is becoming better and is increased and enlarged. Indifference curve or indifference set is the set of basket for which the consumer is indifferent, and indifference map illustrates a set of indifference curve. For consumer, it is an ordinal ranking. As I said to you, it is increasing and enlarging regarding to the direction of the curve from the origin. And when we are looking to the properties of the indifference, there is a monotonicity, which means indifference curve have negative slope and indifference curve are not thick or cannot be thick. And transitivity, indifference curve do not cross each other or must not cross each other or mustn't cross each other. And completeness, each basket lies on only one indifference curve. And one more assumption usually is made, as I said, average preferred to extremes indifference curve are both toward the origin. It is convex to the origin, as I mentioned to you also in the former graph. Monotonicity, because consumers like both goods. Therefore, to meet monotonicity, preference curve must be in these areas on the indifference curve, and it is of course downward sloping. As much as you move along this indifference curve, your preferences is not changing, but your combination probably change. And monotonicity, if more is preferred to less, indifference curve cannot be thick. As you see, if it is a thick curve is realized, A is less than B and B is more than A. Therefore, B would be preferred to A. So this is not the realistic approach for drawing this indifference curve, and it cannot be thicker as it is represented here because it is changing the let's say indifference curve and the utility function regarding to these 2 points between A and B. And it is not able or it is not possible to cross each other because as you see indifference curve in the clothing area in the vertical direction is higher than the indifference curve 1, but when you are approaching to the foot to the x-axis it is intersecting to the indifference curve 1 and it is going downward, and this has meant this is not possible because we suppose that each indifference curve is becoming upper and lower positions and it is not possible to intersect each other. Therefore, we suppose that the B preferred to A. If it is so, then but by the definition of the indifference curve, B indifferent to C and A indifferent to C, therefore B indifferent to A by transitivity, and this is then contradiction. B should be preferred to A due to monotonicity, and as you see here, if it is intersecting each other, this is not realized. Therefore, indifference curve is not expected to crossing each other. And completeness, each basket lies on only one indifference curve, as I mentioned, and you will always prefer one good over the other. For goods A and B, you will either prefer A over B or B over A. It depends where it is located and how the position is. And you will get more utility or satisfaction concerning one of the goods over the other. And as you see here, indifference curve 1 is less than indifference curve 2, and which is going to be represented here. It is intersecting this. If this is supposed to be, there is a line, this budget line is supposed to be, then intersect each. Then this will then gives you some combination of the both, which is not making you the similar utility and similar satisfaction in a given scenario. Therefore, where it is tangent, if this line tangent to the indifference curve 2, we suppose this will be the best possible bundle for the given scenario, which is 5A and 5B is supposed to be the best possible option is given in a scenario, and it is not accepted to intersecting the lower part of the indifference curve, and you don't consider this because you prefer to consider where it is tangent to the indifference curve, this budget line. And for the indifference curve, graphed below are the underlying preferences, indifference curve 1, 2, 3, and 4. There is a complete each line on one line, transitivity no crosses, and monotonic negative slope is supposed. Preference direction is represented here as it is indicated and given here. There is always enlarge and increase, and this is then somehow how it is going to be represented in different cases. And for the indifference curve graph below, as you see, there is a complete yes, transitivity yes, and monotonic no, because want as much x as possible, but don't care about y. So same x and more y are not better off. So no, not monotonic. Therefore, this is problematic here because as you see, it is on the same direction and same line. The marginal rate of substitution is the maximum rate at which the consumer will be willing to substitute a little more of good X for a little less of good Y. It is the increase in good X that the consumer would require in exchange for a decrease in good Y in order to leave the consumer indifference curve between consuming the old basket or the new basket. Therefore, you are always preferring the better off position where it is moving away from the origin. When we are concentrating to the marginal rate of substitution, then it is of course the rate of exchange between goods X and Y that does not affect the consumer's welfare. And it is the negative of the slope of the indifference curve. As you see, the marginal rate of substitution is the delta Y over delta X, which is the slope again of this indifference curve. And for a constant level of preferences, if you like both goods, then the marginal rate of substitution will be negative. And And an indifference curve exhibits a diminishing rate of substitution. These are the, let's say, assumptions and preferences that you have to know before going to these estimations, because you have to know first how it is going to be in the consumer preference and how this utility function and indifference curve are affecting and changing when their position and their application is changing. If more of good X you have, the more you are willing to give up to get a little of good Y, or the indifference curve get flatter as we move out along the horizontal axis and stepper as we move up along the vertical axis. As I said, it is related with this combination. As you see, A is approaching to the Y and B is approaching to the X. Therefore, A has meant the preferences is going to the Y good, and B is going to do X, is more X is preferred. Therefore, the indifference curve, but if it is on the same indifference curve, there is no problem. You have the similar utility on that curve. The indifference curve gets flatter as we move out long the horizontal axis and stepper as we move up along the vertical axis, as it is given the diminishing marginal rate of substitution, because you have to give up something to get something. As you know, this is then the diminisher marginal rate of substitution. And for the following indifference curve, what is the marginal rate of substitution between X and Y is given. As you see, I1, IC1, IC2, and IC3. What type of goods are these? The perfectly substitutes. Does the marginal rate of substitution need to be 1 for each of these? No, could be in a ratio of 2 to 1. X Oreo cookies for each glasses of milk supposed to be as it is given in this example, because it is somehow there is some preferences. When we are graphing this indifference curve with the function, u is supposed to be x and y. The utility function is x and y. And graph the utility curve if utility is equal to 10. Says if the utility is 10, then it is represented as it is given here. 5 to 2 and 2 to 5. As you see, then you have the 2 points and you draw this indifference curve and represent the utility function, which is given already all these things to you. Therefore, when we move to the upper positions, then it is expected utility shifted upper level and becomes higher. As you see now, the utility function is increased to double, then becomes 20, then 20 to x to y, then the preference direction moving away from the origin. And marginal rate, marginal utility and marginal rate of substitution, if it is going to be questioned how it is going to be combined and realized, then marginal utility function for x is then delta x plus marginal utility for u in delta y is supposed to be 0 along on the indifference curve. The marginal, if we're going to let's say find the marginal rate of substitution with this given scenario, with this given formula, the marginal utility will be divided to the marginal utility for y, x and y, and delta y over delta x will be then becomes equal to the marginal rate of substitution. Then this is then represented as it is given in the below equation, where it is derivated. Delta u is delta u over delta x, the multiplied with delta x, then delta u over delta y is multiplied with delta or differentiated y is becoming 0. Then marginal rate of substitution then is, as you see, if you are going to add each other, divide each other and add to the other side, then you will have this delta y over delta x. If you know mathematics a little bit, you will get this easily. Delta y over delta x then will becomes delta u over delta x, which is divided to delta u over delta y. This is the simplest mathematical estimation. Marginal utility and marginal rate of substitution. Positive marginal utility implies the indifferences curve has negative slope, implies monotonicity, and diminishing marginal utility implies the indifference curve are convex to the origin and implies averages preferred to extremes. And if you're going to look to this example where utility is equal to ax squared plus by squared is then marginal utility of x is 2, then you get the derivation. I think you know this, how it is going to be, the derivation. Marginality delta y over delta u over delta x, and marginal utility is given here. For the marginal utility of y is 2 by, because you're going to add 2 to the beside of the b for reducing, for differentiating it in the mathematics. If you know mathematics very well, I think you will understand how it is going to be. Here I will show you. There is also here, let me show you. Okay, yeah. Marginality delta u over delta x, we are getting this as a derivation because delta u over delta x is the derivation. So you have to reduce the power of as it is done here, isn't it? And okay. And marginal rate of substitution, marginal utility of x divided to marginal utility y. Then this is then, as I said to you, it is then 2ax to 2by. Then will gives you, you summarize these two, then will gives you ax divided by. Then marginal utility are positive, as you see here, for positive x and y. And marginal utility of x increases in x, and marginal utility of y increases in y, because this is supporting, as you see. Implication of this, indifference curve are negatively sloped both out from the origin. Preference direction is up and right, and indifference curve intersect the axes. Indifference curve with increasing marginal rate of substitution x to y. If the marginal rate of substitution x to y is higher at basket h at the basket g, the slope of indifference curve u1 will be more negative, steeper at h than g. Thus, with increasing marginal rate of substitution x to y, the indifference curve will be both away from the origin. If you give the example, consider what happens when a utility function has an increasing marginal rate of substitution. We suppose a consumer preferences between two goods x and y can be represented by the utility function uax2 plus by2, where a and b are positive constants. For this utility function, marginal utility x is 2ax and marginal utility for y is 2by, shown on the marginal rate of substitution x to y is increasing. And solution, since the both marginal utility of x and marginal utility of y are positive, indifference curve will be negatively sloped. Then this means that as an amount x increase less along an increase indifference curve, y must decrease compared to x as an amount more. So we know that the marginal rate of substitution x to y is marginal utility x2 divided to marginal utility of y will be equal to 2ax over 2by. This means that as we move along the indifference curve by increasing x and decreasing y, marginal rate of substitution x to y will increase. So we have an increasing marginal rate of substitution of x for y. So figure below illustrates the indifference curve for this utility function. With increasing marginal rate of substitution x to y, they are both away from the origin, which is going to give you in the following examples, as I promised to you, will give you some exercises. And as it is given here, this g and h is become, of course, indifference, and as you see, u2 becomes higher than u1. And indifference curve is equal to the utility concave because of increasing marginal rate of substitution, as it is mentioned, because it is increasing now, not decreasing. And if the marginal rate of x to y is higher at basket h than at basket g, then the slope of indifference curve u1 will be more negative, steeper, as you are observing, at h than at g. And thus, with increasing marginal rate of substitution x to y, the indifference curve will be bowed away from the origin. This is because, as I said to you, it is not convex, it is concave. And because this is increasing marginal rate of substitution, and as you see, G is going to be more, let's say, horizontal, more, let's say, flatter, and H is becoming more stepper, more vertical. Therefore, H this will then the indifference curve U1 will be more negative stepper as you see at H than at G. And if it is given another example, U is equal to xy power of or the root square, the marginal utility of x will be then, as you see, y is in root square divided to the 2 x in root square will be then marginal utility y is then x root square will be divided to the 2y root square. This is then the, of course, differentiation, how you are going to take it. Is more better for both goods is question. Yes, since marginal utility are positive for both, and are the marginal utility for x and y diminishing? Yes, for example, as x increases for y constant, marginal utility x falls. Therefore, since y is numerator and x is the denominator, it is expected that one is increasing and the other one is decreasing, isn't it? Because it is of the position of this equation, or the numerator and denominator. And what is the marginal rate of substitution of x for y? Marginal rate of substitution, again, we are taking the derivation, and it is given here. Y power of, root square is divided to 2x root square, dividing this x root square. This is then the, of course, derivation of this given derivation of this xy root. This is because this is in the root square. You know, if you know mathematics, I don't know, do you know derivations? Because it is a little bit derivations. If you know derivations, there will be no problem for you. You are understanding these examples, because these are the simplest examples that I am giving you. Are you able to understand, or is a problem for you? Because nobody tell me anything. Is there a problem with you? You may tell
Yeah,
me. Is it
it is.
problem?
I
Because
wonder
this.
if the examinations we're going to use the derivations and the calculators, are they going to be allowed or no?
Yes, 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 yes. You have derivation, you have to know, because in the, let's say, micro, we are using derivations because, as I said to you, since you know the slope is also derivation, because you are taking the two difference points for getting the slope, the utility function is also requires some derivations, because you have to use derivation for getting the marginal utility. And since you know the marginal utility is the derivation or differentiation of these two points, then you have to know derivations, and you have to know that root square xy, how it is going to be derivated, because you are going to take the marginal utility of x for the derivating x in the first, and marginal, I show you here, this marginal utility of x is going to be derivated. As you see, then x is derivated, isn't it? Y stay intact. And here, because as you see, you're going to 1 over 2x in root square, isn't it? This is then the derivation of the x, isn't it? Y is stay intact because you are taking the marginal utility of x, because you have to take the derivation of the x. And derivation of the x in a given equation, utility function, which is x, y in root square, is this, isn't it? 1 over 2x in root square. This is the derivation. You know this in mathematics. If you don't know, then you have to memorize your mathematics or derivations for being able to understand, because you have to know to take the derivations, because I cannot teach you the mathematical derivations. This is not our topic. You have to know these things. I think you know these things, isn't it? And for the marginal utility of y, then you are going to see x is stay intact, but you are going to take the derivation of the y, which is 1 over 2y root square, because you know when power of, if it is power, let's say if it is power of 2, x power of 2, then you may say 2x, isn't it? If you're going to get the derivation. You are understanding? If x square power of 2, you have to take the differentiation. This will be 2x, isn't it? And here there is a root square. Therefore, you have to downward this. You have to put into the denominator 1 over 2x or 2y in root square, because 1 over 2 is the root square, isn't it? if the power of 1 over 2 has meant the root square of y or root square of x, isn't it? In the derivations. I think you know these things. Am I right, or you don't remember anymore? If you don't, then I will give you one class, one short introduction next lecture about the derivation, how it is going to be. Just some applications, and you will memorize it if you want. Do you want me?
Yeah, I think, Professor, it would be better if we have um, such a
Application.
class. Yeah,
Because
application.
this is mathematics, and I suppose, or they suppose, you have to know these things. If you don't know these things, then I can I can
Sorry.
refresh you. Yes, please.
Yes. I'm sorry. Maybe I hope if it could be possible, if the students who do not really understand derivatives and all that, maybe we could have like a small meeting face to face, practically try to understand it, please.
With me.
Yes, or any other teacher or student that you can refer.
Okay. I only can give you some exercises online next lecture. I give you some applications to understand how it is. Okay, then you maybe memorize it. But I cannot offer you mathematics class, my dear, because I am economics professor and I don't spend my time for this. This must be. They suppose that you know these things when you are coming to this class. Therefore, I don't know. I don't have. We don't have too much time to offer you a class for the mathematics also. But I can give you just shortly 10 minutes before starting the class for the derivations. Then you memorize it. If you don't know, then I can teach you. You understand? I suppose that you know these things, but I can memorize it for you if you want. Is it okay? Or I can send you some let's say exercises with solutions, and you will understand how it is. Is that okay? Or as I said to you, next lecture I will do some, and then we will see whether it is going to be helpful or not. Okay, then we will solve it. We will solve it probably with somebody. Okay. I
Yes,
don't think that it
Professor,
will be.
if you can do 1 or 2 exercises and send to us, we'll be very, very grateful.
Okay. I will try. Okay, I will find some solution for you. Okay, let's go to the our exercise. As I said to you, we are here because we are taking now the derivations, and the marginal utility is given here for the marginal rate of substitution, and it is y over x because it is summarized. And these things I cannot do because it is supposed that you know how it is going to be, because you have to know mathematics to summarize this. I think you know why it is, isn't it? Because when you are in this class, then you have to know, you will summarize it easily, because you know that when it is y root square divided to 2x root square is divided to x root square divided to y root square, this will goes when it is going to be in the multiplication upside down, isn't it? Then when this upside down, 2x root square and 2y its root square will becomes y or x, isn't it? Because 2y root square will equal to y only. So you remove the root. You understand? Is it clear? I'm talking about this because y root square divided to 2x root square multiplied now, because instead of division, we will then upside down this 2y root square will become divided to x root square. Therefore, when you are going to multiply it with 2y root square to y root square, this will become 2y, and the below the denominator will become then 2x. Therefore, 2 can be summarized, and you have then y over x. This is how it is. This is in mathematics. I don't know if I am able to help you to understand this, but 2 multiplication of root square y and 2y root square will become y, isn't it? You understand what I mean? What I'm talking about? 1y is, I'm talking about this. You got this, and this. When it's going to be multiplied, this will become 2y, isn't it? Because root square y and root square y is y when you multiply each other. You understand? Are you able to understand?
Yes, I think so.
Yes.
And then 2 is going to be removed because 2 over 2 is 0. 2 is 1. And then you remove it from the equation. Therefore, you have y, and you have here 2x if it is in the denominator, and x also will become, when you are going to multiply this, if I'm going to remove this, isn't it, and make it multiply, this will go like this. You understand? I will show you. I will take it here. It will becomes like this. You are seeing what I am doing. Oh, sorry. Let's make it like this. Okay, then I will take it here to make it happy. You see, if this multiplication now, you see, now you are multiplying y to y, isn't it? You got it? Then this will make y, and 2 is removed because you got it? You are understanding? And x is also similarly. I'm talking about this. If you multiply these two, this will make y. You understand? 1y, y root squared, and y root squared will become y. And you have 2 here, then you remove this 2. You remove also this 2. Then you have y over x. You get it? You understand? Is it clear? Or
Yeah,
not
it's
clear?
clear now.
Okay, super. So now I'm putting again the same order. This was like this, isn't it? Okay. Then do the indifference curve intersect the axes? Because this is the simplest differentiation or the mathematical calculations. Do the indifference curve intersect the axes? A value of x is 0 and y is 0 is inconsistent with any positive level of unity, which is expected. And then when we draw it here, then preferences is given here. As you see, is the I indifference curve 2 is becoming, of course, better off. Then the Cobb-Douglas is given here again. We have the special Cobb-Douglas function. You know this, I think, the Cobb-Douglas function. You know this? And in Cobb-Douglas, it is supposed that alpha plus beta is 1 always. And this means if it is 1, there is a constant return. If it is more than 1, it is increasing. If it is less than 1, it is decreasing. Therefore, Cobb-Douglas function, I think you know. If you don't know, then you have to open your economics books and exercise a little bit. Therefore, we have here then the Cobb-Douglas function. Again, we are taking the differentiation for this x and y. For my marginal unit of y, we are taking this, isn't it? You got it? And for the x, we are taking this. Okay, you're taking this. Then the marginal rate of substitution, you divided marginal utility of x to marginal utility of y, will then give you alpha y to beta y, because it is given here, because this will then delete it. It is same. Okay, is it clear? Then marginal rate of substitute only depends on the rate of x and y, not on the total amounts of x and y. So indifference curve for different levels of utility look identical to each other, no matter how far away from the origin they are. Therefore, Cobb-Douglas function is also very good for exercising in this direction. Sorry. And then the perfectly substitutes, if it is given, then u, I, x, and b, y, where a and b is supposed to be constant. As you see, when we are taking the marginal utility of x, we are going to take this only, isn't it? You understand? Because this is 0. There isn't any. Then the marginal utility is becoming 1. X, if there is a x, the differentiation is 1 minus 1 is 1. Therefore, x becomes 1, isn't it? Then you have a. And for the b, you have b, because y power of 1 minus 1 because you get reduce 1 power of for the differentiation, then you have b. You get it? Then the differentiation marginal utility for a is marginal utility for x is a, and marginal utility for y is b. Therefore, marginal rate of substitution x to y is becoming a over b, so that 1 unit of x is equal to b over a units of y everywhere, constant marginal rate of substitution. So we note that marginal rate of substitute only depends on the ratio of a and b, not on the total amount of x and y, because these are the intercept, these are the coefficient which is affecting and changing. Therefore, so indifference curve for different levels of utility look identical to each other, no matter how far away from the origin they are. Is it clear? Then the perfectly substitute indifference, as it is given here, is indifference curve 1, 2, and 3. It is a linear curve is given. Then slope is minus a over b because we have applied this, because this is a linear function. This is the linear equation, isn't it? Therefore, we draw a line, not a curve. Then the perfect complements, u is minimum alpha x and beta y, where alpha and beta are a positive constant, and minimum means take the smaller of the two constants, which means you want 8, let's say, kilogram of coffee with 1, let's say, kilogram of cream. Then the utility function is minimum x to 8y, where x is cream and y is coffee. Then the x to y is then alpha to beta, then is equal to 1 over 8, which is fixed proportion. The marginal rate of substitution here is, of course, 0 or infinite or undefined corner. Then the perfectly complements, which is going to be represent here the nuts and bolts as it is indicated. Then it is given, as you see, it is intersecting the origin and moves to the alpha to be alpha over beta. Then quasi-linear preferences, if it is given, then as you see here, now we have a little bit, let's say, nonlinear equation, v x plus ay, where a is a positive constant, and marginal utility of x is v power of, let's say, multiplied x is not given, power, then is the equal to delta v over x, and delta x is equal to delta v over delta x, where delta small, and marginal utility of y is then supposed to be a, because y 1 minus 1 is 0, because here x is not defined and v is also not given. What is v is we don't know. Therefore, the differentiation of this is given delta v over delta x, but for the y, it is only a. The only thing that determines your personal trade-off between x and y is how much x you have, is the question. Then the quasi-linear preferences is supposed to be somehow linear, but a little bit quasi-nonlinear curve. Then the consumption of beverages is given here. Then marginal rate of substitution diminishes at the quantity of x increases, but does not depend on the quantity of y, because it is not determined. And quasi-linear preference consumption of beverages is given for the indifference curve second. If the indifference curve has same slope on any vertical line, then this will then gives you the same, of course, let's say on the indifference curve 1 utility, and indifference curve 2 same utility. And summary, if we give for this rush and quick presentation, describe consumer preferences without any restriction imposed by budget. In the next lecture, I will put the budget constraint, I will put the indifference curve, and I will try to bring you more step-by-step. I think you need more step-by-step exercises for being able to understand what I am doing, what I have meant, because I don't know whether you are able to understand and follow up this class, because I don't know, since you don't know this differentiation, the things becomes a little bit complicated for you, I think. But I will find some solution for you to make it simple and become more familiar with this issue. And I want to make sure that you are understanding to go further. I hope you are understand what I mean. And the second, the minimal assumption on preferences to get interesting conclusion on demand seems to be satisfied for most people. The ordinary utility function, of course, we are talking about. I stop here. As I said to you, I will make some mathematical differentiation examples for you next lecture, and I will bring some exercises with step by step more clearly to let you understand what I have meant and what I am doing. Then you will understand probably better. But I advise you to go to YouTube. I will upload this video also to YouTube and read the book together. Then you will understand better, because this is not difficult. This is easy if you are understanding the background of the micro. This will then becomes more familiar to you. And if you have any question, please ask me. If you don't, then I will stop here. I'm waiting you, my dear students. Yes, please.
Okay, Professor, let's go to slide 25.
25.
Yes, sir.
This is the video channel. You can watch here also the videos. I have too many. There is comprehensive before going to 25. You said 25, isn't it?
Yes, Professor.
Yes. Here. This one.
Yes, Professor.
What is it here?
I did not actually understand what you were explaining at this level.
Here I said indifference curve cannot cross each other. You are understanding? You forget
Yes, sir.
everything. If indifference curve 1 and indifference curve, look here. If it is thick, for example, there is a difference between A and B, isn't it? And this is not
Yes.
possible. And as you see, if indifference curve is like this means you have to have the all combination at the same utility. But here you are observing the indifference curve 1 and indifference curve 2 is different. Indifference curve 2 is higher than the indifference curve 1, isn't it?
Yes.
But as you are seeing, B is higher than A. B is preferred to A, isn't it? Because at B, you have better clothing and less, let's say, compared to A, isn't it? If you have A, you have less clothing, and if you have B, you have better clothing, because A and B also has a little bit more food differentiation, but clothing shows that on the indifference curve 2, you have better clothing, let's say combination to indifference curve 1 at point A. Therefore, you have to prefer B at indifference curve 2, isn't it? Instead of A, because indifference curve 1 is less than indifference curve 2, and at B, you have better. Am I right?
Yeah, you are right, Professor.
But when you come to C, where the both curve intersect each other, there is a contradiction here, because we said at EC2, you have better EC2 B point, you have better off, and EC1 at point A, you have less. But when these two intersect each other, how this comes, then it is having the same utility. This is not possible. And after this indifference curve 2 goes down, and it is becoming lesser than indifference curve 1. Therefore, indifference curve each other must be better off comparing to the other. If indifference curve is less than indifference curve 2, it should be all same for the all on the line. And similarly, we are expecting that C must be better off than A, but here it says C and A is same because it is on the same line, and C and B it is same because indifference curve says on the same utility line, on the same indifference curve line, you have the same utility, isn't it? But here this is not satisfied because at C you have also A, you have also B combination, isn't it? And this is not possible. You have to prefer B or you have to prefer A because B is on the indifference curve 2, which is higher than the indifference curve 1. And at A, you have the indifference curve 1, and it is expected then lower than B. But you see, it is also indifference curve C. So indifference curve 1 and 2 intersecting each other, and C has also, let's say, components on the both curves, and they have this combination for the both indifference curve. And this is not possible because we are talking about indifference curve is always getting better off when they are getting higher and approaching or moving away from the origin. And here indifference curve moving away from the origin, but suddenly it is intersecting indifference curve 1, and this is not possible because at indifference curve 1 and indifference curve 2 we show that there is better positions at indifference curve 2, but when you go to the C you have both indifference curve 1 and indifference curve 2 combination, and this is not possible. It is a contradiction and this is not acceptable. Therefore we said as a properties indifference curve mustn't or cannot cross each other. Is that okay?
Okay, it's okay, Professor. Now,
Yes.
we are saying that the best combination is the one that is furthest from the origin.
Yes, yes.
If we assume that there is no indifferent curve 1, we have just
Yes.
indifferent curve 2.
Yes.
And we have point B and point C.
Yes.
At this
But this
level,
should, yeah.
at this level,
Yeah.
which combination would be the best?
This should be like
If
this,
we
you
don't have,
understand? Look, this
if we don't
curve
have
should be like,
IC,
look, this should be like this, which is not crossing each other. Maybe a little bit better, but not crossing each other. You understand? This is indifference curve
yes,
1,
sir.
this is indifference curve 2. This is acceptable, but if it is crossing each other like this, it's not okay. Because you have better off at indifference curve 2, and at C you have indifference curve 1, which is, let's say, you may say we are telling on the same utility curve, you have the same combination. You have the same or similar combinations, which is satisfying the same utility. But here we have differences. You understand? Because this is intersecting each other, and if this is 20 and this is 15, how this is comes, then this intersect each other. This is not possible. This is the rule. This is the properties of this indifference curve.
Okay.
As I said to you, if it is everything clear, or if it's not clear, then you will go through to this video and watch and try to understand these differentiations and solve it with mathematical step-by-step, let's say, as you are understanding. If you have any problem with this explanation, because since we are having slides and we are not able to put all equations step by step to explaining the all slides, very let's say basic interpretation. This will then probably better solution for you when you are having this let's say equations or problems and solving with your own capacity with simple step by step, let's say. If you don't, I think these are very easy examples. If you are learning these differentiations, you will understand easily as it is given here. This indifference and this differentiation is very easily represented on the curves and on the examples, and you will understand better, I think. Anyway, as I said to you, you go to the video once again, watch this video and try to understand the examples. You stop the video and try to, I will upload this to the YouTube also, and try to stop this video and solve this problem and check whether it is the same as you are getting the results. If not, then we will solve it again next lecture, step by step, as much as we can, because since we are online, I don't have the application for the mathematical drawing and formulas, but I will try to explain as much as possible for letting you to understand. And as I said to you, I will bring the differentiation explanation in the mathematical, let's say, lectures to let you understand how it is. Okay, this is not difficult. I mean, of course, differentiation, integral are not easy, but I will let you to understand. If you don't know, if you don't have the background for mathematics, I will give you some short briefing and then go to the lecture. Is that okay for you? Because after
Okay,
this,
Professor.
we have a little bit more complicated exercises, then this will then create you problem probably. Therefore, I will let you to understand everything and then go through. Okay. So there will be no problem. I think we will solve it without any problem. And you may come to office. I am also Tuesday. I have the whole day. Then you can come. Then we can discuss it in my office also. Or I don't know, if you are not able to come, then as I said to you, online we will do it. Don't worry. Okay.
Okay, Professor.
Is there anything else or is okay? I think you will go through and you will understand. This is not difficult. I don't know whether you are going to study better at home, then you will understand easily. It is not difficult. I don't know because you don't give me any feedback. Some students says it is difficult, this differentiation, but it's not difficult. I think some students get better understanding for this class because they know differentiation and it shouldn't be difficult. Okay. Anything else you are asking me, or if you don't, then I will stop. If you have any question, please ask me. If you don't, then I will quit. I will finish this class. Do you have anything to ask me? Faith,
No, sir.
Cora,
Thank you.
Toma, Elisaveta, Alec, Abdul. No.
No,
You
sir.
watch.
Professor,
Okay, you watch videos. You next lecture. I said I will give you more detailed. Okay. Okay, then see you then next week on Friday to refresh you with the expected differentiation. Okay, then have a nice weekend. Bye bye.
Bye bye.
Good night.
Thank you.
Bye.
Good
Don't
night.
forget the assignment.
Thank. I will give you. I will upload the exercise also. Don't worry. But let me done first these things for you. Then I will do it. Okay. Bye bye.
Thank you. Bye.
Bye bye.